Hello class, today what we are going to look at is proving that quadrilaterals are parallelograms. In the last video we said what are the properties of parallelograms. All right. What we're going to do in this video is say here's a quadrilateral, prove that it's a parallelogram and not something else. All right. So first we got to see what we're doing. And we have a couple of theorems here. The parallelogram opposite sides converse, parallelogram opposite angles converse, and you'll notice these are both exact same things we talked about in the previous lesson, just going the other way around. What this one says is that if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. This is the converse. And the one we had last time, it said if it's a parallelogram, then the opposite sides are congruent. What we have here is if both sets of opposite sides are congruent, conclusion, it must be a parallelogram. All right. So you see, it's just going in the opposite direction. This one's saying if we know this information is true, then we conclude that it is a parallelogram. In the previous theorems, it was if we know it's a parallelogram, then we can conclude that this information is true. All right. So, parallelogram opposite angles converse. If both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. All right. Let's see, pull this down just a little bit. Okay, the opposite sides parallel and congruent theorem. Notice this is a theorem, this is not the converse. This is a little bit new. What this says is that if one pair of opposite sides of a quadrilateral are congruent and parallel, then the quadrilateral is a parallelogram. So, by definition, both sets of opposite sides will be parallel, and by this theorem we had up here, we said if both sets of opposite sides are congruent, then we have a parallelogram. So you can either prove both sets of opposite sides are congruent, or both sets of opposite sides are parallel. Or if we don't have information on that, we can say one set of opposite sides is both parallel and congruent at the same time. And then we will have a parallelogram. All right. Last one is another converse. If the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. All right. So last time we saw if it's a parallelogram, then we can conclude that the diagonals would bisect each other. Now we have converse. If we know the diagonals bisect each other, we can conclude that the shape's a parallelogram. All right. So let's take a look at some of these. See what we're going to do. Let's move that up. Okay, exercises 1 through 3 state which theorem you can use to show the quadrilateral is a parallelogram. So we are not doing a full-blown proof. We just want to give one theorem that will prove this is a parallelogram. So let's take a look. Number 1, we've got the little arrows there, so we know that the opposite sides are parallel. Just having one set of opposite sides won't do it. We have to have both sets of opposite sides. Let's see. We also know that this same set of opposite sides has a length of A and a length of A. So they have the same length, so they are also congruent. So the opposite sides are both parallel and congruent, just that one set. And so that would be right here, the opposite sides parallel and congruent theorem. Okay, so opposite sides are both parallel and congruent. This is a long one. Parallel and congruent. Theorem. There you go. Opposite sides, both parallel and congruent theorem. Okay. Let's take a look at the next one. What do we have? We have a bunch of angles. Do we have a theorem about angles? What do we know about the angles of a parallelogram? Well, we know that the consecutive angles add up to 180 degrees. We saw that in the last one. And those do add up to 180 degrees, but I don't have a theorem here about that, do I? Nope. That by itself will not prove parallelogram. So, because that could be a trapezoid. Consecutive angles are a trapezoid. At least some of them are. But what theorem did we have? Let's see. Theorems about angles. Theorems about angles. We have parallelogram, opposite angles, converse. Opposite angles of a parallelogram have to be congruent, and opposite angles of this parallelogram are in fact congruent. So that's what we will use. Opposite angles. Angles, it helps if I can spell. I just forgot how to spell angle, isn't that lovely? There it is. Angles. I have angels. It's not quite the same, is it? There we go. Opposite angles, congruent. Opposite angles, congruent theorem. This is not the actual theorem. This is the converse. Because the theorem says we already know it's a parallelogram. The converse says we are going to conclude that it's a parallelogram. So, converse. Converse. Okay, let's take a look at number 3. What do we have? We have some information about diagonals. What do we know about the diagonals of a parallelogram? Well, we know the diagonals are going to bisect each other. So that means this has to be the midpoint of both diagonals, and it is, so this is good. And so we have diagonals bisect each other. What is the name of the theorem? This is the parallelogram diagonals theorem. So in this case, the parallelogram diagonals converse. Because we already know about the diagonals, we are concluding about the parallelogram. Parallelogram diagonals. Diagonals converse. All right. So there's that. We have proven that these are parallelograms based on the information we have. All right. So let's take a look at number 4. What do we have here? 4 through 7, it wants us to find the value of x and the value of y that makes this quadrilateral a parallelogram. All right. So let's see what we have. We have x here, we have x plus 40 there, and we have 4y. What do we know about parallelograms? Well, these are all angles. We know that opposite angles are congruent, right? So, yeah, but that gives me 3x minus 20 equals 4y, and that gives me x and y, and I can't do anything with x and y. I have to have only one variable. Can't solve for 2 at a time. So we're going to have to do something with these that both have x's. Well, let's see here. We also know that opposite sides have to be parallel, right? So this side has to be parallel to that side, which means our consecutive interior angles here have to be supplementaries. So we're going to have to take these two and make them add up to 180. So let's do that. 3x minus 20 plus x plus 40 equals 180 degrees. Combine like terms, we have 4x, and negative 20 and positive 40 is a positive 20, equals 180 degrees. Subtract the 20 from both sides, and we have 4x equals 160, divide by 4, and x equals 40. That's one of the things we were looking for x. Okay, so we have x equals 40. The next question is, how do we find y? All right? Because all this does, this just makes these two sides parallel. We need both of them to be parallel. And so we could, now that we know what x is, we could take x, plug it in here, and have these two add up to 180. Or we could take x, plug it in there, and have this one equals that one. And that's what I'm going to do. So we have 3 times x, which is 40, minus 20 equals 4 times y. Well, let's see here. 3 times 40 is 120. 120 minus 20 is 100. So 100 equals 4y divided by 4, and we have 25 equals y. And there we go. Now we have x and we have y for number 4. All right? Okay, let's take a look at number 5. Number 5, we're looking for x and y. What do we have here? We do have two expressions with an x. We have two expressions with a y, right? And these are both on diagonals. All right. What do we know about the diagonals of a parallelogram? Well, in order for this to be a parallelogram, the diagonals have to bisect each other, right? That was the parallelogram diagonals converse. So that means that this half of the diagonal has to equal this half of the diagonal. So 6x has to equal 4x plus 10. So that should be easy enough. 6x equals 4x plus 10. Move the 4x over, so we end up with 2x equals 10, divided by 2, and x equals 5. Okay, so we've got our x, now we just need to find y. Let's see here. Y is also on diagonals. We have 2y on this half and y plus 1 on that half. So, diagonals have to bisect each other, right? Parallelogram diagonals converse. We had that up here on number 3. So, set them equal to each other. 2y equals y plus 1. Subtract the y from over there, and we end up with 1y equals 1. That was pretty simple. And there it is. Not too bad. Okay, let's see. We're doing this for all of these, so let's take a look up here at number 6. Let's see, can I get both on the screen? There we go. So, what I want you to do is pause the video, work out number 6 and work out number 7, use the properties of a parallelogram, those theorems, those converses there, and then come back and check your work. Okay, let's see, you are back. Number 6, what do we have? We need x, we need y. Well, let's see, x is on the sides, 10x plus 7 and a 12x minus 9. Those are both on the sides. They're on opposite sides, so I can set those equal to each other. So let's go ahead and do that. Let's see, 10x plus 7 is going to equal 12x minus 9. So first we're going to move the 10x over, so that gives me 7 equals 2x minus 9. Add 9 to both sides, and I end up with 2x equals 7 plus 9, which is 16. Divide by 2, and we have 8 equals x. Like so. Now let's find y. What do we know about y? We have y degrees over here. That's inside an angle. The only other angle we have is 106. Those are opposite each other, and the parallelogram opposite angles theorem, converse, says that if I can make these two be the same, then this will have to be a parallelogram. So I want to set those two equal to each other, which it's just y, so it's just y equals 106. That was easy. No work at all there. This has to equal that. Okay, so that one was pretty simple. Let's take a look at number 7. Let's see, all of this is sides, and we know that opposite sides are congruent. So that means that the 70 is going to equal 4y plus 2, opposite sides. So we'll go ahead and do that. We'll do y first this time, because why not? 4y plus 2 equals 70. Subtract 2 from both sides, and I have 4y equals 68. Divide that by 4, and y equals, let's see, 6 divided by 4 is 1, with 2 left over. 28 divided by 4 is 7. And so y equals 17. Okay, let's find x. let's see, we have 5x plus 16, and over here we have 6x minus 1. Those are on opposite sides, so in order to make this a parallelogram, these two have to be congruent. So let's set them equal to each other so we can make them congruent. 6x minus 1 equals 5x plus 16. First, we subtract the 5x from both sides, which is leaving with 1x minus 1 equals 16. Add 1 to both sides, and x equals 15. So hopefully that's what you got. Y equals 17, and x equals 15. And we could have done the other order. It doesn't matter on this one. All right, so that's not too bad. All right, down here, I have for you just a little summary. 5 different ways to prove that a quadrilateral is a parallelogram. Okay. Option number 1, show that both pairs of opposite sides are parallel. That is the definition of a parallelogram. So if both sets of opposite sides are parallel, it's a parallelogram. Option number 2, show that both sets of opposite sides are congruent. This is the parallelogram opposite sides converse. If you know they're congruent, then you can conclude that it is a parallelogram. This is the converse. All right. Next, we know that the opposite angles of a parallelogram have to be congruent, so if we can show that both pairs of opposite angles are congruent, then we can conclude that the parallelogram is, the quadrilateral is a parallelogram. Again, this is the converse of the parallelogram opposite angles theorem. All right. We could show that one set of opposite sides are both congruent and parallel. Okay, so basically we are showing this is true for just one side instead of showing it's true for both sides. All right, but you have to show two things congruent for one set of sides, or one thing congruent for both sets of sides. Okay, this is the opposite sides parallel congruent theorem, not a converse. This is the theorem. All right, last one, we need to show that the diagonals bisect each other. So if you can prove that those two diagonals cut each other in half, parallelogram diagonals converse says that it will be a parallelogram. All right? And that is how you prove that a quadrilateral is a parallelogram. Not too bad. Hope you found that useful, and I will see you next time.